In the following example, we're asked to find the volume of rotation, or rotating the area bound by the curve x squared minus 4y squared equals 4, x equals 3 about the y-axis. So if we begin by drawing x equals 3 on our curve, here's x equals 3, we're rotating this region in here around the y-axis. So we'll indicate our axis of rotation here. In terms of rectangles, we need to recognize that this is actually two separate functions. If we solve this, which we need to do to graph it on our calculator here, this is y equals plus or minus the square root of x squared over 4 minus 1. So that's solving this equation for y. So the positive square root is on top, the negative square root is on the bottom. So this is two separate functions. If we use a dy rectangle, a dy rectangle is going to have the left side on this curve, the right side on the line x equals 3. However, when we move into quadrant 4 here, this curve now, remember, is different. This is the negative square root. So now it's a different curve. That would mean a second integral. However, if we draw a dx rectangle here, then the top will always be on the positive square root and the bottom will always be on the negative square root. In that case, the dx rectangle will work fine. And that means we need x values, so this is 2 here, and this is 3. And because this is our axis of rotation, this is our rectangle, it's parallel, we're using the shell method. The shell method means we need a radius, a height, and a thickness. Radius means the distance from the axis of rotation to the rectangle. That's x. The height means the height of the rectangle. So just as we did for area, we're going to take the top of the rectangle minus the bottom of the rectangle. So the top of the rectangle is going to be the positive square root of x squared over 4 minus 1 minus the bottom of the rectangle, which is negative square root of x squared over 4 minus 1. Negative negative means positive, so when we simplify that, we're going to have 2 times x squared over 4 minus 1 to the power of a half. The thickness, of course, is dx. Solving this then, the equation for volume is equal to 2 pi times the integral from 2 to 3 of the radius times the height that should be squared there radius times height times thickness. Now if we notice this has an exponent, so we can't multiply through with the x. We can take the 2 outside, so we'll do that, but we recognize in here this is x squared. The derivative of this part is going to give us x with a constant, so we can use u substitution. So for u substitution then, we're going to set u equal to the part in the bracket, so x squared over 4 minus 1. That makes du x over 2 dx, which means 2 du equals x dx. Substituting then, this 2 we remove, gives us 4 pi. Integral from 2 to 3. X dx becomes 2 du. So we'll stick the 2 there, put the du at the end. X squared over 4 minus 1 is u, so that's u to the power of a half du. Integrating, 4 times 2 is 8, we'll take that 2 outside. U to the half becomes u to the 3 over 2 over 3 over 2, and that has to be evaluated from x equals 2 until 3. The reason I emphasize x equals 2 is we don't want to substitute in for u here. This is x values. We need to put back in our x value before we can substitute. So if we continue over here, this becomes 8 pi times 2 x squared over 4 minus 1 to the 3 over 2 over 3. That 2 came from the bottom, and that is evaluated from 2 to 3. Substituting in 3, substituting in 2, and subtracting gives us 23.4 units cubed.